After all accumulated West Pacific waters reach the eastern boundary region, the equatorial region becomes stable. No east-west temperature asymmetry means no unstable balance between wind and gravity. This stable status in the Pacific is unusual and won't stay this way for very long. This is the beginning of the El Niño recovery. Water near the east equatorial region slowly spreads north and south. Sea surface height gradually decreases with this movement, and the 20 degrees Celsius thermocline ascends. This water movement is called discharge. At the beginning of the El Niño recovery, the Pacific Ocean starts to develop the east-west temperature asymmetry on a very small scale. First, the Peruvian coast becomes cooler because of coastal upwelling, and the offshore waters stay warm. Next, the eastern equatorial region becomes cooler because of equatorial upwelling, and the western equatorial region stays warm. This temperature difference makes the wind blow to the west. When the wind starts to blow to the west, the east-west temperature asymmetry gradually becomes larger. Finally, when the size of the east-west temperature asymmetry extends to all of the Pacific Ocean, the El Niño recovery is finished. The Pacific Ocean becomes unstable again. This unstable condition is normal. From the model output, you can see the El Niño recovery. First, in the second panel, you see sea surface height decrease and the 20 degrees Celsius thermocline become more shallow by the process of discharge. Next, in the top panel, cooler water shows up in the Peruvian coastal region because of coastal upwelling. Following, you see the cooler water gradually emerge at the surface of the equatorial region around 120 degrees west. You can see the east-west temperature asymmetry in the top panel, and this asymmetry makes the continuous westward winds at the equator. The second panel shows the continuous westward winds as black arrows. Gradually, warmer water accumulates in the western Pacific. The third panel shows the 20 degrees Celsius thermocline in the western Pacific becoming deeper. Finally, the recovery is completed. After a strong El Niño, a La Niña event frequently occurs. The reestablishment of the east-west thermocline tilt overshoots the normal tilt. This stronger than average tilt makes cooler water available to upwelling. This cooler water has higher nutrients, which produces higher productivity. La Niña conditions rapidly return to normal, usually after 1 year.